Next, we'll look at some special products. So when we multiply something like x minus a times x plus a, so that the only difference is the sign in the middle, this ends up being x squared minus a squared. We saw this example just a minute ago when we did x plus 8 times x minus 8. X plus a squared, if we work this out, we get x squared plus 2ax plus a squared. So we square the first term, multiply them, and then double that, and then square the last term. The only difference is if we change that to a minus, would be changing the middle sign to a negative. Our next products are cubes. So we have x plus a cubed. This is x cubed plus 3 x squared a plus 3 x a squared plus a cubed. If we change that to a negative sign, we would have x cubed minus 3x squared a plus 3x a squared minus a cubed. So we don't change all the signs, instead we alternate them. Our last special products, x minus a times x squared plus ax plus a squared. If we were to multiply this out, we actually get x cubed minus a cubed. Same thing here. If we change this to x plus a and x squared minus ax plus a squared, we would get x cubed plus a cubed. And for all of these special products, if you were to multiply these out, you can achieve these formulas on your own. For example, x minus 5 times x plus 5 would be square the first one minus square the second one. When we're dealing with a square, we would square the first thing, multiply x times negative 4 is negative 4x, times 2 is negative 8x, and then we square the last term. X plus 2 cubed. Well, we start by doing x cubed. We then square the first term times the second, so 2x squared times 3. So that would actually be 6x squared. We then have the first term times the second squared, which would be 4x times 3, which is 12x. And then we cube the last thing. 2 cubed is 8. In our last example, x minus 3 times x squared plus 3x plus 9. Well, this would just be x cubed minus 3 cubed, which is x cubed minus 27. Next, we'll look at division. And before we do this, we'll do a very basic division problem, which is 842 divided by 15. So when we do this, our first question in long division would be how many times does 15 go into 84? And we get that it goes in 5 times. We would then multiply down. 5 times 15 is 75. And then we would subtract these numbers. 84 minus 75 is 9. And we would bring down the 2. The next question, how many times does 15 go into 92? The answer is 6. And then 6 times 15 is 90. Subtract that, we get 2. So we have the answer is 56 with a remainder of 2. And in general, whenever we do these, we have our quotient, multiplied by the divisor plus the remainder will always be equal to the dividend. We can check that here. Our quotient was 56, the divisor is 15, and the remainder is 2. And if you work all of that out, you get 842. So now our idea is to use this method to do polynomials. So for example, it is important to note whenever we're doing these that we cannot skip terms. So on the outside we'll have x squared plus 0x plus 1. And in the inside, negative 6x cubed minus x squared plus 3x minus 5. So we want to know x squared times what is negative 6x cubed. Well, we would definitely need a negative 6 in there. And to get from x squared to get to x cubed, we would need to multiply by x. So negative 6x. Multiply down. Negative 6x times x squared is negative 6x cubed. Negative 6x times 0x would be 0x squared, and negative 6x times 1 is negative 6x. And just like before, we now need to subtract. So we're going to change the sign all the way through. These will cancel. I now have negative x squared plus 9x, and we bring down the negative 5. X squared times what is negative x squared? Well, that would just be negative 1. Negative 1 times x squared is negative x squared. Negative 1 times 0x is 0x. And negative 1 times 1 is negative 1. And then once again we subtract. So we change the sign all the way through. These will cancel. I now have 9x squared minus 4. 9x minus 4. And then that's it. I now have my quotient and my remainder. And in particular, we usually write this as our quotient plus the remainder over the divisor. We'll do one more. This time the outside is x squared plus x plus 1, and the inside minus 4x to the 4th. We don't want to skip terms here, so we'll write 0x cubed plus 3x squared minus 7x minus 1. X squared times what is negative 4x to the 4th? Well, we would need a negative 4 in there, and to get from x squared to x to the 4th, we would need another x squared. So negative 4x squared. Negative 4x squared times x squared is negative 4x to the 4th. Negative 4x squared times x would be negative 4x cubed. And negative 4x squared times 1 is negative 4x squared. We would change the sign all the way through so we could subtract. This would be 4x cubed plus 7x squared, and we would bring down the next term. X squared times what is 4x cubed? Well, we would need a 4 and another x. 4x times x squared is 4x cubed. 4x times x is 4x squared, and 4x times 1 is 4x. Once again, we want to subtract, so we'll change the sign all the way through. 7 minus 4 would be 3x squared minus 11x, and we bring down the 1. X squared times 3 is 3x squared. So 3 times x squared is 3x squared, 3 times x is 3x, and 3 times 1 is 3. Once again, we subtract. And this would give us negative 14x minus 4. So our answer Negative 4x squared plus 4x plus 3 is the quotient. And then we would take our remainder over the divisor.